By the end of this lecture, you're going to know how to configure parameterized routes in our route definition object. You're also going to learn how components can be notified with what the parameter values are when the URL gets visited. And you're also going to know how we can have optional parameters in our routes. So sometimes we need part of the path in one or more of our routes to be a variable. A common example of this is an ID. So let's say we have a blog and each article in our blog has a unique ID. So the URLs for each blog article might look like this. So we have /blog/1/2/3 and then /4. Now we could write a route for each article like this. Each individual blog article would have its own components, a blog 1 component, blog 2 component, blog 3 component, and blog 4 component. But a better solution is just to have one route with one component called blog component and pass to the blog component the number part of the URL. That's what we call a parameterized route, and it would look something like this. We have one component called blog component, and the path has a variable called ID. We know it's a variable since it begins with a colon. So a path can have any number of variables as long as they all start with a colon and they all have different names. Another thing to know about parameterized routes is that non-parameterized routes always take priority over parameterized routes. So in the configuration in front of you, if we visited /blog/moo, we would actually show moo component, even though /blog/moo also matches with blog component. That's because the non-parameterized /blog/moo route takes priority over the parameterized /blog/id route. But how do we actually pass into the blog component the value of the ID variable? If we visited /blog/1, how does blog component know that the ID is 1 and therefore to show the appropriate article? To do that, we use something called an activated route. We first import it and then we inject it into the constructor of our blog component. It then exposes an observable through its params property, which we can subscribe to and then be notified with whatever parameters there are in the route. So now if we navigated to /blog/1, the number 1 would get emitted on the observable and this would get printed to the console like this. So for the rest of this lecture, we're going to continue building the iTunes search application we've been working on in the other lectures. But as we perform searches with the application, one thing to note is that the URL doesn't change. Therefore, if I refresh the page after I perform a search, then I lose all of my search results. The state of my application is lost. So let's turn the search route into a parameterized route where the search term is in the URL. So if I refresh the page, it will then perform the same search and get us back to where we were. So I'm going to start by just adding in a variable called term to our route configuration for our search route. But now if I reload the page and try to navigate to /search, you can see that we're actually getting shown the home component. Now the reason for this is that now our URL /search doesn't match a route. So we are falling back to the catch-all route, which just shows us the home component. To match our new parameterized route, we would have to navigate to something like search/u2. And now we're shown the search component. We actually need to pass a parameter to match the root. So therefore, to support both /search and /search/u2, we need two roots in our configuration, like so. The first root will only match /search, and the second root will match a search with a search term. So now let's import the activated root and inject it into the constructor of our search component. We import it from Angular router, and then we expand out search component. And then I inject it onto the constructor of our search component. And just like our example in the slides, I'm just going to log the parameters to the console for now. So if I inspect element, let's have a look at the console. And now the URL is /search/u2. We are using the parameterized URL if I view that page. Refresh the browser. And now you can see we're seeing the parameter of our parameterized root being printed to the console. Now if we navigate to /search/u2, we see an object with the term of u2 being printed to the console. We see the parameters being printed to the console. But we are not actually performing a search for u2. To do that, we need to call the doSearch function from the activated root subscribe callback. So we need to call this doSearch function here from within our subscribe callback. And I'm just going to remove word wrapping from the editor to make it clearer. So to our doSearch function, we're actually passing in the value of the term property, which is u2. So after this, now when we visit the search/u2 URL, we actually perform a search for u2 as well. But now if we search for another term, for example, I'm going to search for love, we get the results we expect, but the URL doesn't change. If we look at the URL, it's still saying /search/u2. So that leads me to an important note. When using routing, if some part of the state of your application is in the URL, then you need to update your application by navigating to the correct URL. That way the URL matches the state of your application, and if you bookmarked or shared the URL, then visiting it again will get you back to the same state. So for us, the search term itself is part of the URL. So to perform a search, we need to navigate to the correct URL. So now if I open up the code that I had collapsed previously, we can see that when we click the search button, we're actually calling the doSearch function. So instead of this, I want to call another function, a function called onSearch. I then create the function onSearch on our component. And then when the onSearch function gets called, I'm going to use the router to navigate to a URL. But if you remember from the previous lecture, in order to use the router, we need to inject it into our constructor. So let's inject it as well. And for the link params array, I'm first going to pass in search. And then the second parameter in our path is the actual search term itself. So I'm just going to pass in the variable search term, which gets passed to the onSearch function. So now let me close the console, refresh the application. The URL contains U2, so it's performing a search for U2. And now when I search for love, we can see the URL changes to love. This change in the URL triggers the activated root callback here. And in this callback, we call doSearch. And in the doSearch function, we actually issue the search to the API. But the important thing here is that the URL and the state of our application are now in sync. So now that I've searched for love, if I was to refresh the application, we would then get to the same state we were before, because it's going to redo the search for love and show it on the screen. So before we finish off, I'm just going to go back to the root configuration, and I'm just going to have a relook at the solution where we have two roots configured. One for when there is a search term and another for when there isn't a search term. Another way to think about this is that the variable term is optional. It might be present and it might not, and we want the app to function correctly in either situation. Angular has a mechanism to support these optional parameters. And to demonstrate it, firstly, I'm going to get rid of the second root with the fixed term variable, leaving us with just one root to support our search. And then in the onSearch function, instead of navigating to a root with the fixed term variable, we can instead pass in an object containing whatever parameters we want. So as the second parameter to the link params array, I'm now passing an object with a key of term, and the value is the term that we're passing in. So now if I go back to the root of our application, let me refresh the application actually. Now when I search for something like love, the search functions correctly. We're seeing the love results on the bottom of the page, but if I look at the URL, you'll see something a bit strange. Instead of seeing /search/love, we're seeing /search semicolon term is equal to love. This is something called a matrix URL notation, and it's a series of optional key value pairs separated with a semicolon character. And it still works with the activated root. So the parameters being passed to activated root, or being emitted on the observable of activated root, still contain the parameters in the URL. Okay, that's perfectly fine, but now the term parameter is actually optional. And since it's optional, it sometimes can be blank. So if we actually just provide no term, we still seem to be performing a search. We're actually performing a search for the string undefined because, well, we're passing in no term. It's trying to do a search with a blank value, and a blank value just resolves to undefined, the string undefined. So to solve this, let's just add some defensive coding to our subscribe callback here. So only if the params contain a key of terms do we actually perform a search. So now if I refresh the page and our search URL has no parameters, that's fine. We're not actually performing a search. Now when I search for love, the URL changes. So it now contains term is equal to love. And now when I refresh the page, because the URL contains the search term, we're now still performing the same query and showing the results on the screen. And again, if we search again for something else, the URL changes to support our new search term. So to summarize, with parameterized roots, we can support variable paths in our routes. And Angular also supports optional routes via passing in an object to the navigate function and using the matrix URL notation. So far in this section, we've only shown how we can output one component on the page, depending on the route. In the next lecture, we're going to show how we can have nested routes and output multiple different components on the page, depending on the URL.